Hello guys, my name is Harshit and today we are going to start with a development of this thing that is ChemoraPy, and I am focusing it to make a NumPy like library but for chemistry. Actually, if you know, mathematics, physics and chemistry are my favorite, and around next month I am planning to drop a new video in my channel, and for that thing this thing is very important, not the complete thing, but the thing that we are adding in it is quite useful for the next upcoming project. And so let's start. So first of all, if you want to know, we are going to start with today is Aufbau Principle. If you don't know about this, don't worry. If we just go on internet and check Aufbau Principle, it is like this. So if you know and have interest about chemistry, that you probably know about electrons, protons, neutrons, because chemistry is all about that. So if there is, let's say, an element x, so iska matlab then it let's say this is an element x, then it has a z is equal to atomic number and in a neutral atom atom z is equal to number of electron e minus. Yeah, e minus. And the case of protons and neutrons is sorted, but in atomic models the this electron is not sorted, it is something problematic. So for that there is an Aufbau principle. Actually today the thing we are gonna to do is writing the its electron fillings, and it is not just about Aufbau. It considers several things like Aufbau principle, Pauli exclusion principle, and Hun rule. All things, not Hun rule, but Aufbau and Pauli exclusion principle. And for that today we are going to do this, and it is electron filled in atomical order of their uh, order of increasing energy in starting from lowest available energy level to higher. So if you wanted to understand this, just go and check out something that helps you. So this, first of all, this is gonna be in Python, and second, let's start doing it. So I hadn't done anything. So here we are, we just created a function above, and this z represents to atomic number. Now if if we see the last latest and last known element is 118, and that is OG, and for that we go. So its last is 7p6. It belongs to p block, of course, and it has 7 orbitals, and in 7th orbital there are 6 elements. So if for this, if we want to understand how they are going to fit, they are like this. It is 1s 1s note, we are writing full for the 118th element. So it is, and s has two elements. Sorry for clarification, s equal to 2 electrons, p have 6 electrons, D have 10 electrons. Similarly, the last subcell, that is F, have 14 electrons. We cannot in F we cannot insert more than 14 electrons, and if according to Aufbau the arrangement of orbitals are like this: 1s, 2s, it is considered equal also 2p, 3s, as the OG had 7p6, and the last thing that we tell use is 7p, and they are like something like this. So now we had to define this principle and actually the whole thing in these things, and I am keeping that so that if you want to contribute in its development, you can come and see this all and do whatever you want to do. No, if you want to develop it, actually if you want to contribute. So according to me the logic should be like this: if we create similar lists and just add logics to enter the number of electrons in each, so it would be like let's first create the lists, and here they and here we actually created the orbital and subcells according to this, like first orbitals. If I add y, this is s1 s2, so actually first orbital, so actually small n represents 2 orbital, and when n is equal to 1 it contain only s subshell, n subshell, n equal to 2. When it is n equal to 2, s have sp, and when it has n equal to 3, it is s comma p spd. For when n equal to 4, it is spdf, and so forward till for today. Today known there is 7, and from 4 to onwards I need to add 4 plus etc. There are these subcells that are used spd, that is spdf, and I had created list that this first character is represents the subshell, then second represents orbit, then it contains a list. And for this I am giving the electron a value, and electron e is equal to, sorry, I am giving e equal to a value for, let's say, for equal to 1. Now what I am trying to do is that when we will take input this z is which is equal to atomic number, that is z is equal to atomic number. And what I think, then with every step we just add e in every these lists and so on. So now first of all I would like to write, we need to run a loop, that is we are using while loop, and while z is greater than or equal to 1, this condition is true, and else when z becomes 0, this condition becomes this condition becomes false. So we need to now think what to do, and mm, I was originally thinking about 10 minutes, but for writing this we had the time that I gave is not standing a chance, I think so. So we might not end its development to in the one video. We might take 2 to 3 videos, and actually I also don't have much time, so we might not be able to explain this all today. So if we just look at what it is, when we go here, so for this is actually the basic logic and basic thing that we need to understand. Name this video introductory. In second video we will be developing the whole thing, and I promise that we will complete this in this tomorrow. And it has these values also, nothing to explain, but I might try to explain what else we will do with this, and in next video we will complete it by with our whole energy. And for that time, stay healthy, stay curious, and do what you want to do.